AI. It's literally just numbers. People talk about AI as if it's God or the devil. No, it's literally numbers. To understand AI, you have to understand normal software first and understand the difference between deterministic systems and probabilistic systems. First, normal software. This is the deterministic system. So, what is a deterministic system? It's one where if you put something in, you know what comes out. It's called algorithms, which is just step-by-step instructions to get something done. This is normal computing. If you're not hungry and not thirsty, not A and not B, you rest. If you're hungry and not thirsty, A and not B, you eat food. If you're not hungry and thirsty, not A and B, you drink water. If you're hungry and thirsty, A and B, you eat and drink. This is how it looks like written in pseudocode. It's basically a series of true and false statements. If A and B is or isn't this, do this or that. That's it. Why this is the case is because of hardware, the way computers are built. Let's go through hardware 101. Every thinking your computer does runs through transistors. Transistors are electronic gates. So electricity runs from the left through the middle to the right. If there is no electricity in the middle, the left energy can't go to the right. And therefore, if there's electricity, it's on or a 1. If there's no electricity, it's off or a 0. If you put them together, it's a bunch of gates opening and closing a bunch of other gates. This is the if something is a bunch of zeros and ones, it'll do something else to a bunch of zeros and ones. This is called Boolean algebra. It's a bunch of true, false, as well as and or not. This is logic based. It's predictable, it's non-creative, it's computing. This is deterministic. Second, AI software. This is the probabilistic system. An AI model right now is just a word generator. That's literally it. This graph shows how close Coca-Cola, oatmeal, and pizza is to like water and like food. The position of the dot on the graph is how similar it is to food and water. So the numbers is how close each word is to food and water. You map it onto coordinate system. And basically, a model is just a bunch of words that equals a list of numbers. First, every word gets a number for where it sits, its meaning. Then the model uses those to produce numbers for what words come next, the chances. So this is how an actual model looks like. What you have to care about is the list, the position, and the number. The list is the list of other words or tokens to the original word. In this example, all of these are other words mapped to food. The position is the position of the other words. So the second number in all of the lists to all these words is the same word, which is food. And the number is the probability this word is going to be used. So this is 12% that this number is going to be used. Since in maths, 1 is 100%, so 0.12 is 12%. The numbers should add up to 1 or 100%, but I made an oopsie, okay? But just know all of these numbers should add up to 1. The actual numbers are infinitesimally small numbers like 0.00000003927 or something. It generates the next tokens based on the most probable tokens. The higher the 0.xx number, the more likely it'll generate that token. The tokens are chunks of words, sometimes whole words, sometimes pieces. Literally just imagine like the strawberry is unhappy, broken into the strawberry is unhappy, and each one of those are tokens, or 1 2 3 4 5 broken into 1 2 3 and 4 5. So if we go back and look at the values in the tables, the highest values are the most likely token that should appear next. In this example, if food comes up, food is the most likely next token. If meal comes up, food is the most likely next token. If water comes up, token on the 0.88 axis is the most likely next token. If you think about in terms of space, it's like 3D if you only have 3 values. Every value is another dimension. So if we were to map the values in a 3D space like this, the numbers would look like this. It's literally just coordinate system. For each more number added, one number has to be added to all the lists, and it's the same thing as adding another axis to this space. This is called the meaning space because the mappings and the coordinates represents meaning, and technically it's a space. And then it goes all the way to a bunch of axes and dimensions that people can't fathom right now. The AI is trained on data and comes out with a bunch of numbers with a bunch of axes that the AI engineers didn't plan. And then this is another part. It goes through some more processing through something called a transformer. And then it gets a new number, and that number is the probability for the tokens. And the most likely next token tokens are chosen. The thing is, the model might not even choose the most likely token. It might choose the second most likely token or the third most likely token. This is to make the model more creative. That's model creativity, or else it will just be, I think, deterministic. So AI engineers create algorithm. Here are the parameters, here are the rules, here are the data. Go make some numbers or something. They don't even know the axes or what the resulting numbers mean. It just works. This is called linear algebra, which deals with scalars, vectors, matrices, and tensors, as well as dimensions, operations, and transformation. This is percentage based. It's unpredictable, it's creative, and it's intelligence. This is probabilistic. I'll go deeper into these topics if you guys want me to. Just subscribe and click the bell to let me know you want to watch more videos like these. And check out the next videos in the series here. And check out the playlist in the description.